Hello friends, let's today represent small amounts of discrete data using stem and leaf diagram. So in the stem and leaf diagram, obviously you have the data in the form of a stem, which is I've shown in brown in color here. So this is your stem and these are your leaves. So the data will look somewhat in this format, and that's the reason the name stem and leaf diagram. So let's see how we can represent such a data. So let's say I have a percentage of scores of say 15 boys, and these are the scores, and I have to represent it using stem and leaf. So the stem and leaf, what it says is that the first digit, in fact the last digit of each score will become the leaf, and the stem will be the rest of the data. So here if I check the first digit in each of the numbers, so if you see the first digit you have 5, then you have 6, 7, 9. So these are the first digits, the first unique digit. So what I'll do is I'll make the stem. So the stem will be obviously vertical. So that would be, we'll start with 5, then you'll have 6, 7, then you have 9, but for reference we'll keep 8 to maintain the uniformity, and then you have 9. Now we'll plot the leaves. So this is the stem. So this becomes your stem. Now let's start off with the leaves. So we have 58, 55. So we have 8, we have 5, uh, and then we have 3, right? So we'll start off with the lowest digit. So we'll have 3. Then we'll have, so we have 53. That means this reads as 53. Then we have 55, 58, and there is one more 58. So whoever reads the data, you will read it this way, that the values will be 53, 55, 58, and 58. So these are your leaves for this particular data. Now the next one. Next one is 6. So with 6 you have 1, so that's 61. Then you have 67. So you have one more 61. So I'll take one more 1. Then we have 64, 62 and 64. So here we have 2, here we have 4, and then we have 7. So this is the leaf for this data which has 6 as the first digit, and we also have 69. So we'll have 9. So this becomes the leaf for the 6th part. Okay. Now let's take the 7. Now for 7 we have 72, 79, 77. So accordingly we can write. So I'll have 2, 7, and 9. So this is for this particular part. Now for 8 we don't have any data, so we'll leave it blank. And for 9 we have 2 and you have 7. And I can just close this here. So So this is how a stem and a leaf diagram looks like. Now, suppose we have one more data, let's say one more set of data wherein, they say that for girls, there are 15 scores for girls as well. So let's say percentage scores of 15 girls. And let's say the data is, let's say 51, 52, 61, 62, 63. Then you have 71, 72, 73. And you have 81, 82, 83, 91, 92, 93. So let's say we have, again we should have 15. So we have 1 2 3 4 5 7 8 9 10 11 12 13 14, and let's say I have one more 99. Now if I have to just draw a diagram to make a comparison, I'll write here boys, and for girls I can just write the data here. So that would be, so we have 1 and we have 2. Then for 6 we have 1, 2, 3. Then for 7 we have 1, 2, 3. For 8 we have 1, 2, 3. And for 9 we have 1, 2, 3, and 9. Now this becomes a comparison data. So now this now exactly looks like a stem and the leaves. and this is how you can read the data. So here I'll write girls. So I hope you understood the concept. So this is your stem. So we just as you understand, the leaves are always the last digit of the data, and rest of the digits form the stem. So if I want to read the data for girls, I'll read it as 51, 52, then 61, 62, 63, 71, 72, 73, 81, 82, 83, 91, 92, 93, 99. So this is a good way of representing discrete data, but however, we should only use this in case of small data, because if you have a large amount of data, it will become difficult to make such a huge data, right? So hope you like this video. For more such videos, please like and subscribe to the channel. Take care. Bye bye.